Good evening, class. So, in the series of Fundamental of Maths, in the earlier days we had covered the topics related to coordinate geometry. So, today we are going to start a new topic that is entitled as factorization. The factorization topics, it is basically covered in the sessions of in the syllabus of 9 and 10th and the higher secondary also, but it is the base. It covers the basic concept in the series of Fundamental of Maths. Today we are discussing about the topic factorization, and it is the core subject. The factorization, it is the core subject of the mathematics, and we will be dealing with different types of numericals, different which will make our concept more clear. So the factorization, as we had studied also in our previous classes regarding the concept of the factorization. Suppose if we are taking a particular number, suppose if we had taken a particular number 81, suppose we had taken a particular number 81 and we are factorizing it, suppose if we are taking, so we are factorizing it like this, 3, it will be like this, 27, 3, 9, 3, 3 and 3, 1. So if we are elaborating 81, we can write it into 3 into 3 into 3 into 3. So if we are dividing 81 with the number 3, then we are finding that we are getting the remainder as 0. 381, suppose we are dividing it with the 3. So in this case, if we are dividing the number 81 with 3, we are getting remainder as 0. So we can say clearly, it is evident here that the number 3, it is a factor of 81. It means the number which divides a particular number, and post dividing, if we are getting remainder as a 0, then we can say that the divider, that is divisor, it is 3. 3 is the factor of the particular number, that is 81. So this is the basic concept. The factorization means it is the process of simplification. Suppose we are dealing with the one numerical concept here with the natural numbers, and if we are extending this concept to the polynomials, in that case also there will be complex numericals, and we will be using different concepts of factorization so as to know what all factors of that particular number is there. We had taken the example of a natural number 81. We will be taking another examples also which will make our concept more clear. So again we are taking a simple example which will make our concept more clear. So suppose we had taken a number 49. Understood? As we are knowing that it is a square of 7. If we are multiplying 7 2 times, we are getting this number as a 49. So if we are dividing this with the 7, 7 7s are 49, then we can say that 7 is a factor of 49. 7 is a factor of 49 because post division from 7, we are getting remainder as a 0. Now we will be extending this concept to the concept of polynomials. We are extending this concept to the concept of polynomials. First of all, we will take a short, you can say, description of polynomial. As the name suggests, the polynomial means having more than one terms. No matter whether it is a constant or variable, but having more than one term, it is the polynomial. And we will be taking some of the examples of the polynomial. Suppose the polynomial, it is comprised of two parts. One is the constant, and the other is variables. In the constant, the polynomial, it is broadly classified. It is comprised of, you can say it is comprised of two parts, that is constant and variables. The constant, we can check the variables and the constant. As the name defines itself, the constant, it means whose value is fixed, whose value remains fixed, it will not change its values. So constant, we can say, we can take it as a natural numbers 3, 4, 5 up to infinity. It means all the natural numbers starting from 1 and ending up to infinity in a particular sum, in a particular algebraic expression or in a polynomial are termed as constant. Their value will not change. Once it is prescribed, once it is recommended here, their value will not change. That is constant. If we are switching over to the variables section, suppose we are taking x, y, z, etc. So the variables are those whose values are changing. So the x, y, z. So these are termed as variables. So how we are getting polynomial? If we are multiplying the constant with a variable, so 3x, 4y, 5z, these all are polynomial having 1 degree, that is their power is 1, x to the power 1, y to the power 1, z to the power 1. Suppose if we are using a different type of polynomial, suppose we are adding or subtracting, we are using different mathematical operations in order to define a particular expression, that is also a polynomial. 3x plus 4y plus 5z. This is also a polynomial. This is also a type of polynomial. So we can define polynomial as it is a mixture. It is a mixture of constant and variable in which there is a particular relationship between the constant and variable, and this relationship, it is established as a result of mathematical operations between the constant and variable. These mathematical operations may be subtraction, addition, multiplication. Any of the mathematical operations can be induced with the same. So we had defined a polynomial in the 1 degree. The degree means the power raised, the positive power raised. Suppose if there is a one expression is there, 3x to the power minus 1 plus 4y to the power minus 1 into z. So in this case, we can say that there is a negative power of minus 1. So it will not be considered as a polynomial. The power should be positive, the degree should be positive. No matters whether it is a constant. If it is alone also there, 3 into x to the power 0. Suppose if any alone term is there, 3, we have to categorize it in the form of polynomial or not. So we can say easily that it can be written as 3 into x to the power 0. So here also it is a mixture of constant and variable, and the variable is raised to the power of 0, the positive 0. Thus we can say that this is also categorized as a polynomial of degree 0. So this is the concept of polynomial in nutshell. So we will be elaborating this concept slowly, and we will be inducing this polynomial into the factorization. So we will be starting some of the basic concepts of factorization. So in the factorization of this you can say numericals, we are dealing with different types of polynomials. Only polynomials. It will be a mixture of constant and variable. So we are dealing with the different types of polynomials. We will be taking some of the examples and some of the formulas which are widely used in the factorization. The first and foremost formula is a minus b the whole square. That is a square plus b square minus 2ab. A plus b the whole square, it will be expanded as a square plus b square plus 2ab. A square minus b square, it will be written as a plus b into a minus b. A cube minus b cube, it will be written as a minus b, a square plus ab plus b square. A cube plus b cube, it will be written as a plus b, a square minus ab plus b square. Then a minus b the whole cube, it will be written as a cube minus b cube minus 3ab a minus b. Then a plus b the whole cube, it will be written as a cube plus b cube plus 3ab a plus b. Then we will be writing a plus b plus c the whole square, a square plus b square plus c square plus 2ab plus 2bc plus 2ac. So on. So these are the basic formulas which we will be using in order to solve the process, in order to simplify a particular problem, and we will be knowing the factors of the same, the multiples or the factors. If we are dividing with that particular expression, we are getting remainder as a 0. That is known as the factor. So a minus b the whole square, a plus b the whole square, a square minus b square, a cube minus b cube, and a minus b the whole cube, a plus b the whole cube, a square plus b square plus c square. So this is the basic formula, this one. So these are all the basic formulas which we will be using later on to solve the numericals, the complex numericals in the polynomial in the factorization section. So we will be taking some of the examples which will clarify our doubt and which will make our concept more clear. So suppose we will be starting with the basic sum and we will be extending our concept to the other numericals also. So we will be taking one sum which will be making our concept more easy. Suppose the one sum is there 18x square y minus 24xyz. This is the sum and we have to factorize it. It means that we have to get the factors of the same, through which if we are dividing this expression, we are getting the remainder as a 0. So if we are getting this type of sum, 18x square y minus 24xyz, so we will be taking the common. So what is the common here? See, 6, x, y both are common. It will be 6 to the 18 x. So it will be 6 to the 18 x square y minus 4 z. So this is the term 6xy into 3x minus 4z. So these are the factors of this. So if we are checking the solution here, we will be getting this one as a factor. So this is the basic thing, 6xy 3x minus 4z. So these are the two factors of this particular expression. If we are dividing this with these factors, we are getting the remainder as a 0. So this is the simplest numerical we have taken to make our concept more clear. We will be taking some more examples, the simpler examples only, which will help to make our concept more easier. Now the second sum is there, x square plus 1 by x square minus 2 minus 3x plus 3 by x. Understood? So we have taken one numerical and we will be solving it with the concept of our earlier induced formulas, a minus b the whole square or a plus b the whole square. So in this case, if we are writing it like this, x square 1 by x the whole square minus 2 into x into 1 by x. This is the first part. Up to this we had transformed this particular equation into a minus b the whole square. That is a square plus b square minus 2ab. Now in this term, if we are taking minus 3 as a common, it will be x minus 1 by x. In the last two terms, minus 3x plus 3 by x, if we are taking minus 3 as a out common, we are getting x minus 1 by x. Now if we are solving it, it is in the form of x minus 1 by x the whole square minus 3x minus 1 by x. So we had got the like terms, x minus 1 by x. We have got the like terms. We will be taking x minus 1 by x outside. Now it will be x minus 1 by x. Understood? And it will be minus 3. So this is the particular factor of this particular expression, of this particular sum. So we have got the two factors, x minus 1 by x and x minus 1 by x minus 3. So if we are dividing this with this expression with this one or this one, we are getting the remainder as a 0. So it is elaborating here, it is more evident that These two are the factors of this particular expression through which we are dividing the expression, we are getting remainder as a 0. This is the basic concept of the factorization. So we will be taking some more examples of different types which will clarify our concept more easy, which will render more transparency. So we will be taking one example. It will be in the form of a square minus b. Earlier we had seen a minus b the whole square or a plus b the whole square formula. The sum based on these two formulas, a minus b the whole square or a plus b the whole square. Now we will be dealing with the sum, which is basically it is based on a square minus b square. The formula a square minus b square. We will be taking one more examples regarding this, which will render more transparency. So suppose it is 49x square minus 1 by 4. So it will be 49x square minus 1 by 4. It is in the term of a square minus b square. So it will be 7x the whole square minus 1 by 2 the whole square. So it will be a square minus b square. So a square minus b square, what will be writing with a plus b into a minus b. So it will be 7x plus 1 by 2 into 7x minus 1 by 2. So these two are the factors of this particular sum. These two are the factors of this particular sum. If we are multiplying this term into this term, this term into this term, we are getting this. If we are dividing alone also this one into this and this one into this, we are getting remainder as a 0. So this is the particular way to solve this particular problem. So it is in the form of a square minus b square. We will be taking one more example which will elaborate, which will render more transparency on the same. Suppose if we are taking one more example like this, we will be solving one more example. X square plus 1 by x square minus 3. So this one will be x square plus 1 by x square minus 3. Suppose the question it is coming like this: x square plus 1 by x square minus 3. So this particular expression, we have to transform this particular expression in such a way that it is stabilizing some of the relationship in the form of it is taking the form of a square minus b square. So first of all, we will write this expression in the form of a square plus 1 by x the whole square minus 2 into x into 1 by x. Okay, if we had written here minus 2 into x minus 1 by x, because we have to transform this particular equation, this particular expression in the form of a square, a minus b the whole square or a plus b the whole square. So as to do so, we are using the concept of a square plus b square minus 2 into a into b. So minus 2 into a into b we are coming, it is minus 2 here, it is minus 3 here. So what we will put here, so it will satisfy this particular equation. So in this case, we will be writing here, it is minus 2 here it is. If we are writing here, suppose if we are writing here plus 5, or you can say minus 1. So if we are writing here minus 1, so we will be checking whether the transformation which we had done, it is satisfying the above equation. Without making any change, if it is satisfying the above equation, then only we will proceed further. So it will be x square plus 1 by x square minus 2 into a into b, and it will be minus 1. So if we are cancelling also, it is minus 2 minus 1 minus 3 x square plus 1. So the transformation which we had done, it is satisfying the above equation without any changing, without any changes. So we will be writing in the form of a minus b the whole square, a minus b the whole square up to this term, and it will be minus 1 the whole square. Because if we are squaring the 1, it will make no effect, it will not make no changes in the equation. So now this particular equation, it is coming in the form of a square minus b square. As we had already studied, a square minus b square is equal to a plus b into a minus b. So we will be writing this x minus 1 by x minus 1 and x minus 1 by x plus 1. So these two are the factors of this particular numerical. So today we have covered the two concepts, the various concepts. We had discussed some of the formulas, 7 to 8 formulas. Among those 7 to 8 formulas, we had covered the two types, a minus b the whole square and a plus b the whole square and a minus b the whole square and a square minus b square. So these three formulas which we had covered here. So today we had covered only 3 formulas among 7 formulas, and so for tomorrow we will be covering the next formulas which are more complex in nature, but we will be solving mechanically. Each and every step we will be solving very easily so as to render more transparency and making our concept more clear. So thank you for the today, and most probably tomorrow we will be covering the more formulas which I had already told you it is more complex in nature. And just observe my video, see my video, like my video, and if possible share it also. And if you have any doubt, if you have any issues, please do comment in the comment box so that I will be getting your feedback, and it will be more beneficial for me and for you also, and I will be trying to resolve the problems which you are facing as soon as possible. So thanking you for the day. Good night. Have a nice day.